Can you talk a little bit about kind of what a production 3D printing company looks like in terms of different job roles? So you were the first or kind of material, like you're the materials guy, but like what is the business? Like how does it work? Like who's involved? Like what do you do? And
Perfect.
not
Yeah.
specific projects or anything, but like what does that mean?
Yeah. So great question. So for most of these service bureaus, they make money when they print parts and ship completed parts to customers, right? And the term complete might be, hey, it's printed, but then it has to go through these steps, such as, hey, it needs to be surface finished, it needs to be machined, we need to inspect it, may need to be heat treated, maybe we need to emboss, a serial number on the side, and so on. And all that stuff are requirements that end customers, or we call them OEMs, request, right? Your big aerospace primes, your GEs, Lockheed's, Boeing's, they may have internal capabilities, but they also, contract out manufacturing to other suppliers. So production companies and service bureaus, again, are just suppliers and players in this entire supply chain. And our role was basically to print parts, print good quality parts, make sure they meet the requirements that are needed, and basically ship them to the customer. So everything over there was focused on speed, and quality. Get parts out, get them out quick. So my role, it was focused where I was, um, you know, playing in between quality, where hey, sometimes in order to define what the spec is in the internal spec, like hey, how do we know that this machine is actually functioning properly? What is our calibration methodology? What is our qualification methodology to, after a machine's been serviced or if a machine's been moved, how do we make sure and ensure that the machine is producing good quality material and we are ready to go back and start off with production? That's one part of it, so I wrote specs on those lines. Then on the like development side of things, there might be a customer saying that, hey, I need 5,000 widgets to be printed out of a 316 material, but I need these particular mechanical properties to be hit, right? So we have the end requirements. So we need to go and say, all right, so what do we have? We have the standard, parameters off the shelf. We're going to use that. There's a standard AMS heat treatment for 316. We'll try that, and then we'll machine them into tensile bars, and we'll test it and see what these tensile properties are. And then you realize, oh, it doesn't actually meet the requirements. So where can we actually change up things a little bit? So associated with that, doing parameter development to get better properties, or doing a heat treatment adjustments to get better properties. There are a bunch of things you can adjust, but there isn't a lot of wiggle room, especially in production, because if you make a lot of changes upstream, that might result in a lot of problems for you downstream. So things like that. So that's another type of thing that was done. And then the third real role that I played was in research and development. So, I was like the one-man research and development team. If there's a cool idea that we wanted to test out, because it was the early days of AM, not many people had machines. And so there were a lot of customers who were interested in getting parts printed out of new materials, exotic materials. They'd be asking, hey, can I, print this thing that looks like an antenna on a non-metallic substrate? Or can I, intentionally print porous parts, where I can grade the porosity? So these are research and development questions. And so whenever we'd find, some open time on a machine, I dive in and then get this experiment carried out, and then we'd have a result. And basically that result would, help form the basis of a presentation or a paper, something which just helps us, brand and, increase our visibility in the marketplace, so that people are like, oh yeah, these people know what they're doing. We should go
Yeah,
speak to them.
I remember a lot of the tables and a lot of good material science stuff you guys put out a number of years ago with that. So it worked. I definitely saw it.
Awesome.